Chapter 2 Structure of Atom Part 1 Learning Outcomes. After watching this video, you will be able to know about the discovery of electron, proton, and neutron and their characteristics. Describe Thompson's, Rutherford's atomic models and their limitations. Define atomic number, atomic mass, and isotopes. Let us start with introduction of atom. Atoms are the fundamental building blocks of matter. The atom has been derived from Greek word atomio, which means uncuttable or non-divisible. The atomic theory of matter was first proposed by John Dalton. Main postulates of Dalton's atomic theory are: all matter is composed of atoms. Atoms cannot be subdivided, created, or destroyed in ordinary chemical reactions. However, these changes can occur in nuclear reactions. Atoms of an element have a characteristic average mass which is unique to that element. Atoms of any one element differ in properties from atoms of another element. Dalton's atomic theory was able to explain law of conservation of mass, law of constant composition, and law of multiple proportion very successfully. However, it failed to explain the results of many experiments. For example, it was known that substances like glass or ebonite, when rubbed with silk or fur, gets electrically charged. This indicates there is presence of charged particles in the atom. Discovery of the electrons. In 1897, J.J. Thompson used a cathode ray tube to deduce the presence of a negatively charged particle. A cathode ray tube is made of glass containing two thin pieces of metal called electrodes sealed in it. The electrical discharge through the gases could be observed only at very low pressures and at very high voltages. The pressure of different gases could be adjusted by evacuation of the glass tubes. When sufficiently high voltage is applied across the electrodes, current starts flowing through a stream of particles moving in the tube from negative electrode to the positive electrode. These were called cathode rays or cathode ray particles because these particles starts from the cathode. Results of this cathode ray tube experiment. The cathode rays start from cathode and move towards the anode. These rays were not visible, but their behavior could be observed with a certain kind of material called fluorescent or phosphorescent materials. In the absence of electrical or magnetic field, these rays travel in the straight line. In the presence of electrical or magnetic field, the behavior of cathode rays suggested that cathode rays consist of negatively charged particles, and these particles are named as electrons. The characteristic of cathode rays do not depend upon the material of electrodes. Nature of the gas present in the tube means all elements must contain identically charged electrons. Thomson's cathode ray discharge tube experiment to find charge to mass ratio of electron. The measure of ratio of an electrical charge to the mass of an electron by using the cathode rays discharge tube and applying electrical and magnetic field perpendicular to each other as well as to the path of electrons. This is the setup for finding the charge to mass ratio of the electron. Thomson's cathode ray discharge tube. By carrying out accurate measurements on the amount of deflection observed by the electron on the electric field strength or magnetic field strength, Thomson was able to determine the value of E by m, that is charge by mass ratio of electron, and that comes to 1.758820 into 10 raised to power 11 coulomb per kg. So this is the SI unit of the charge of the electron is determined by Robert Millikan. He performed an oil drop experiment to determine an accurate value for the charge of the electron. By repeating the experiment for many droplets, he calculated the charge of electron as 1.6 into 10 raised to power minus 19 coulombs. Mass of the electron was determined by dividing charge of electron by charge by mass ratio of the electron, and that is 9.1 into 10 raised to power minus 31 kilogram. Conclusion from the study of the electron. Atoms are neutral, so there must be positive particles in the atom to balance the negative charge of the electron. Electrons have so little mass that atoms must contain other particles that account for most of the mass. Let us discuss discovery of the anode rays. E. Goldstein noted that cathode ray tubes with a perforated cathode emit a glow from the end of tube near the cathode. Goldstein concluded that in addition to cathode rays, there is another ray that travels in the opposite direction from the anode toward the cathode. Called them canal rays or anode rays. Properties of the anode rays. Anode rays consist of heavily positive charged particles. The charge to mass ratio of these particles was found to be dependent upon the type of the gas used in the discharge tube, because anode rays are formed by the gas particles. That's why the mass ratio depends on the gas. Some of the positively charged particles carry a multiple of the fundamental unit of electric charge. Anode rays get deflected into a direction opposite to that of cathode rays in electrical and magnetic fields. The smallest and lightest positive ion was obtained from hydrogen and was called proton. Let us discuss discovery of neutron. James Chadwick conducted an experiment in which he smashed alpha particles into beryllium. The experiment results showed release of massive neutral particle to which Chadwick named as neutrons. So these are the alpha particles, and when these strike on beryllium, there is the liberation of these neutral particles which are named as the neutron. So there are three subatomic particles: electrons, protons and neutrons. These are the charges, mass and location of the particles. Thomson's atomic model. J. Thompson proposed that an atom possesses a spherical shape, radius approximately 10 raised to power minus 10 meter, in which the positively charged is uniformly distributed. The electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. Thomson believed that electrons were like plums embedded in a positively charged pudding, thus it was called the plum pudding model. This is also compared with watermelon. The red part of the watermelon is considered as positive charge of the atom, and the black seeds which are embedded in the red part, these are considered as the electrons. Limitations of Thomson's atomic model. Although this model was able to explain the overall neutrality of the atom, but was not consistent with the results of Rutherford's gold experiment. Rutherford's gold foil experiment. Rutherford bombarded very thin gold foil with alpha particles. A stream of high energy alpha particle from a radioactive source was directed at a thin foil of gold metal. The thin gold foil had a circular fluorescent zinc sulfide screen around it. Whenever alpha particles struck the screen, a tiny flash of light was produced at that point. The results of scattering experiment were quite unexpected. According to Thomson's model of atom, the mass of each gold atom in the foil should have been spread evenly over the entire atom, and alpha particles had enough energy to pass directly through such a uniform distribution of mass. It was expected that the particle would slow down and change directions only by a small angles as they passed through the foil. But the observation of Rutherford's experiment were quite different. Most of the alpha particle passed through the gold foil undeflected. A small fraction of the alpha particles was deflected by small angles. A very few particles, 1 in 20,000, bounced back, that is, were deflected by nearly 180 degrees. On the basis of the observation, Rutherford drew the following conclusions regarding the structure of atom. Most of the space in the atom is empty as most of the alpha particles pass through the foil undeflected. A few positively charged alpha particles were deflected. The deflection must be due to enormous repulsive force, showing the positive charge of the atom is not spread throughout the atom as Thompson has presumed. The positive charge has to be concentrated in a very small volume that repelled and deflected the positively charged alpha particles. So Rutherford gave his nuclear model of atom. According to this model, the positive charge and most of the mass of the atom was densely concentrated in extremely small region. This concentrated region was called nucleus by the Rutherford. So nucleus is discovered by the Rutherford. The radius of the atom is about 10 raised to power minus 10 meter, while that of the nucleus is 10 raised to power minus 15 meter. The nucleus was surrounded by electrons moving in a very high speed in circular paths called orbits. Thus Rutherford's model of atom resembles the solar system, in which nucleus plays the role of the sun and the electrons that of revolving planets. Electrons and the nucleus are held together by the electrostatic force of attraction. Drawbacks of Rutherford's model of atom. It could not explain line spectra of atom. The Rutherford model cannot explain the stability of an atom. It could not explain the distribution of electrons around the nucleus and the energies of these electrons. Why the atom is unstable according to Rutherford's atomic model. The revolution of the electron in circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particle would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable and hence atom would not exist. Now, atomic number. Atomic number of an element is the number of protons in the nucleus of each atom of that element. For example, carbon, this is having 6 protons in its nucleus, so its atomic number is 6. Similarly, phosphorus is having 15 protons in its nucleus, so its atomic number is 15. Mass number. Mass number is the number of protons and neutrons in the nucleus of an isotope. Oxygen is having 8 protons and 10 neutrons, so its mass number is 18. This is the isotope of oxygen. In the case of arsenic, there are 33 protons, 42 neutrons. That's why its mass number is 75. Isotopes. Isotopes are the atoms of the same element having different masses due to varying number of neutrons. Like hydrogen has 3 isotopes: protium, deuterium and tritium. All these isotopes of hydrogen are having 1 proton and 1 electron each. But there is the difference of neutrons in these. In protium there is no neutron, in deuterium there is 1 neutron, and in tritium there are 3. In tritium there are 2 neutrons.